Hey class, we made it to the last day. I know it feels like it has been forever, but we are here. We do still have some review to do today, but hopefully you'll be able to get through this and check it off your list. It feels really odd saying bye to you over a video. It's really sad, even though my students normally run out the door and are not sad that they don't see me again. This situation just has made it so much different and feels so different of saying bye over video, but I hope you all have a fantastic summer. You enjoy your time at home. I am one of the very few teachers in the building who are not moving classrooms next year, so you'll still be able to stop by and see me in the same place. I'd love to see how you're all doing. Hopefully we'll all be together in the building and at WHS at the start of next year. So today we are going to be looking at and reviewing factoring. Okay, and we're just going to be looking at trinomials, and we're going to be looking at special cases. So remember, trinomials is when we have three terms, right? Tri means three. Okay, so let's say we want to factor something like w squared plus w minus 30. Okay, when we're factoring a trinomial, we're always doing that a times c type thing. So we want to multiply, right, our a times our c, where our a in this case, because we don't really see it, but our a is really a 1. Okay, so we're taking 1 times negative 30, which gives us a negative 30. And then once we get that value, we're going to ignore the negative for a minute and just think about types of numbers that multiply up to 30 to start with. Okay, so we have 1 and 30, 2 and 15, 3 and 10, 4 and nothing, 5 and 6. Now the next number I would write down is 6, but it's already over here, so I know that I'm done. Okay, then I need to figure out my signs. Now we had that sort of chart that we used as a crutch to start with. I'm going to write it down, but remember by the test, you guys were doing this without the chart just fine. So, right, the list says, ax squared. That if everything is positive, we know we want positive factors. Right, if a times c is positive, but we need it to add up to a negative, then we need two negatives. Right, and if we need one of each sign, then we need the larger one to be the same sign as b. I'm sure you've all kept fantastic notes, and you can find your notes from class, and you can just pull that chart right out. Or maybe not, but there it is if you need it, okay? So in this situation, right, we have negative 30, and we need to add up to a positive. So to multiply to a negative, we need one negative and one positive, and we need the larger one to be positive. So that's our right-hand side. Okay, and we want it to add up to b, which in this case is a 1. So we're going to go down our list here of smalls being negative, large being positive, and figure out which set will add up to 1. Okay, and you can use your calculator however you sort of went about going that, but we should figure out that it's negative 5 and positive 6. Now, in this situation, our a is positive. Okay, and when our a is positive, we can go the shortcut, and we can just write our answer into the two binomials, where I'm going to use the negative 5, and I'm going to use the positive 6, and my variable goes in front of each of those. And so my answer is a w minus 5 and a w minus 6. And as a reminder, right, that can be written in either order. So if you had w plus 6 and w minus 5, that would be totally fine as well. Now, we're not always in this situation where our a equals 1. So sometimes, right, we're going to see something where a is something other than 1. And if a is something other than 1, then we need to do a little bit, I don't know, more work is the right word. We need to do some different work to get the answer. So let's say we have something like 7x squared plus 31x plus 12. Okay, we're still going to start this out the same. So we're still going to take that a times c, right? That idea doesn't change. So we'll take 7 times 12, use a calculator or whatever you need, and we get, oops, not 81, 84. And then we're going to start listing our multiples of 84, right? So 1 times 84, 2 and 42, 3 and 26, 4 and 21, 5 and nothing. Let's see. 6 and, I'm trying to think about what I need to say for the video and do this at the same time. 6 and 14. 7 and 12. 8 and nothing. 9 and nothing. 10 and nothing, 11 and nothing, and 12 is there. This is, sorry guys, my math is off right here. That's a 28. There's my problem. Okay, so once we make our list, sorry for all of those who are like, Mrs. McKinney, you wrote it down wrong, right? I always do that when I'm in class too, so no different when I'm making a video. Now, once we have our list, we're going to figure out what adds up to 31. And we have positives and we have positives, so everything is positive. So we have a positive 3 and we have a positive 28. Now, here's where we have to do some remembering because we cannot just put this into two binomials. When A is not 1, we have to split up this middle piece. And this middle piece becomes a positive 3 and a positive 28, where both of those get an X. Okay, this last piece stays. And the first piece comes down as well. That first and last term just come down with it. And so we've rewritten this into something that's equivalent, but that is now 4 terms. And once we have something in 4 terms, we know how to factor that by grouping. And that's what we practiced yesterday, right? So we're going to split this in half. We're going to find our GCF of each side. So over here we have a GCF of X. And if you forget how to do factoring by grouping, go back to the video from yesterday. Over here we'll have a GCF of 4. And so we'll put our GCFs together and our common binomial together, and we'll get an X plus 4 and a 7X plus 3. Okay, let's take a look at our special cases. And remember, we have one type of special case, if you remember, we have one type of special case that's a little bit unique because it looks exactly the same and the work is exactly the same. There's just sort of one hiccup we have to keep in mind. So let's say we have something, I don't know, c squared minus 24c plus 144. Okay, and we go to factor this and we multiply a times c. So 1 times 144 is a 144. And so we make our list. 4893 and... Okay, I don't trust myself now because I messed up the last one. 48, 4, and 36, 5 and nothing. Right? You can just pick up your calculator and divide, like 144 divided by 1, 144 divided by 2, 144 divided by 3. 7 is nothing. 8 is 18. 9 is 16. 10 is nothing. 11 is nothing. 12 is 12. Okay, we have a negative followed by a positive. So in this situation, we want 2 negatives, right? So we need all of these to be negative. And then we want the set that will add up to negative 24. So now if we go there, right, you might have to check in a calculator, but that's our negative 12 plus our negative 12. This is a situation where we can use the shortcut because A is equal to 1, so we're set there. So we'll do a C minus 12 and a C minus 12. And again, if this is free response, that's totally fine. But if it's multiple choice, you need to make sure that you're recognizing these can be put together into one binomial as C minus 12 squared, right? Exactly backwards of what we did Tuesday. Tuesday, when it was written like this, we turned it into 2. So today, when it's written as 2, we can turn it into 1. One more special case I want to take a look at, and that's when we have our 2-term special cases, a difference of squares. So maybe we have 64 y to the 8th minus 25. Okay, so remember when we have a difference of 2 squares, it's going to be 2 terms. It has to be subtraction, which this is. And then we need to have a square root of each of these numbers. So taking a square root is something we should be more familiar with now that we've done more of that this year. Okay, we didn't know it when we first started factoring, but in your calculator, right, if you don't know it off the top of your head, you can do second, x squared, and then 64 equals. Okay, but 8 times 8 is 64. 5 times 5 is 25. Right, and we always took half of the exponent because the square root of y to the 8th, right, we would write out y 8 times and find the number of pairs, and there are 4 of them. Okay, so we know that this now has perfect squares. When that's the case, right, we went into 2 binomials where the order stayed the same. So the 8y to the 4th is going first in both of them, and the 5 is going second in both of them. And then one of the binomials gets an addition sign, and one of the binomials gets a subtraction sign. And class, that is it for review. You have like 6, 7, I can't remember the exact number of questions for your assignment, and you are done with math for Algebra 1. Have a fantastic summer. I would love to hear from you all. I hope that you're all well, and hopefully I will see you next school year.